Heavy machinery is already impressive, but some machines go far beyond normal engineering. These are the giants, experiments, and mechanical oddities that look more like creatures from science fiction than real industrial equipment. Built for extreme environments, strange terrain, or unusual jobs, many of them were one-of-a-kind prototypes that should have disappeared decades ago. And yet, amazingly, several of them can still start, move, and work today. From walking steam shovels to land trains hundreds of feet long, from Antarctic land ships to swamp-floating excavators, these weird machines show how far engineers will go when traditional designs aren't enough. This list explores 14 of the strangest heavy machines ever built, and the incredible fact that many still roar to life. The walking Marion steam shovel, the machine with legs. The walking Marion steam shovel is one of the strangest and most fascinating machines ever built. A massive excavator that didn't use wheels, tracks, or rollers. Instead, it walked. Built in the early 1900s by the Marion Steam Shovel Company, this bizarre machine moved across job sites on giant mechanical feet, lifting and shuffling its entire body like a slow-moving steel creature. While it may look like something from a steampunk movie, a few of these machines still survive, and shockingly, some can still be started today. The reason this machine had legs was simple. Early construction and mining sites were often muddy, swampy, or covered in soft soil. Heavy machinery with wheels would sink, and crawler tracks hadn't been perfected yet. Marion engineers came up with a strange but effective solution. An excavator that could lift itself and take steps. The shovel used steam-powered winches to raise its massive wooden platform and slide it forward. Then it would set itself down, brace, and repeat the motion. The process was painfully slow, but it worked, allowing the machine to cross terrain that would trap other equipment. At its heart, the Marion was a full steam-powered excavator. A vertical boiler fed steam to multiple cylinders that powered the hoist, swing mechanism, and crowd operation of the bucket arm. Thick steel cables lifted the huge bucket, which could dig deep pits or load railway cars with dirt, gravel, and ore. Everything about the machine was oversized. Its boiler, gears, and wooden support timbers created a working platform the size of a small house. The operator controlled the shovel from a hot, noisy interior, filled with steam lines, clanking gears, and the constant hiss of pressure valves. What makes the walking Marion so impressive today is its durability. Many machines from the early 20th century were scrapped, but a handful of Marions survived simply because they were too heavy to bother dismantling. Some were left in forests, quarries, or abandoned mines and sat untouched for decades. Enthusiasts and preservationists later returned to these sites, cleaned boilers, lubricated gears, and discovered something incredible. The machines still worked. Even after nearly a century of exposure, the simplicity and strength of steam machinery kept these giants alive. Today, the walking Marion steam shovel stands as a reminder of an age when engineers weren't afraid to experiment with radical ideas. It remains one of the weirdest heavy machines ever built, and one of the only excavators in history that literally walked its way into legend. The LeTourneau land train, the 600-foot off-road monster. The LeTourneau land train is one of the strangest, longest, and most jaw-dropping heavy machines ever built. A 600-foot-long, diesel-electric off-road freight train that didn't need rails. Designed by R.G. LeTourneau in the 1950s and 60s, the land train was meant to haul massive loads across remote regions where roads, rails, and supply lines didn't exist. Arctic tundra, desert terrain, mud flats, this monster was built to cross all of it, and incredibly, one surviving unit can still be started today. Instead of a locomotive pulling a few trailers, the land train acted as a single-linked vehicle with up to 12 or more articulated cargo cars. Each car had its own electric motor in the wheels, powered by huge diesel generators in the front power unit. This meant the entire machine had dozens of powered wheels at once, giving it enormous traction on loose ground. Where trucks would sink or stall, the land train simply kept crawling forward, its giant tires gripping almost anything. The most famous version, The TC497 Overland Train Mk2 stretched nearly 600 feet and used a jaw-dropping 54 wheel-mounted electric motors. Its lead power car carried 4 massive gas turbine engines borrowed from aircraft technology, giving it more than 5,000 horsepower. Despite its size, the articulated steering system allowed the entire train to snake around obstacles. Operators described the experience as driving a long, flexible metal caterpillar across the wilderness. Inside, the lead cab looked more like an aircraft cockpit than a truck. Dozens of gauges, switches, and monitoring systems helped control the turbine engines and electric drive motors. The crew lived inside the massive command car, which contained bunks, a kitchen, radios, and long-range navigation equipment. The land train could travel for hundreds of miles without refueling, carrying fuel, cargo, and supplies for entire remote operations. The land train's biggest mission was supporting Cold War military outposts in places like Alaska and Greenland. The U.S. Army needed a machine that could transport gear across frozen territory where conventional vehicles were useless. The land train performed well in tests, climbing slopes, crossing ice, and towing heavy loads. But with the rise of heavy-lift helicopters and the construction of Arctic roads, the program was eventually canceled. Today, the last surviving LeTourneau land train sits in Arizona. Volunteers occasionally fire up its turbine engines, and unbelievably, the giant still rumbles to life. As one of the weirdest heavy machines ever built, the LeTourneau land train stands as a reminder of a time when engineers thought bigger, much bigger, than anyone else. The Athey wagon wheel tractor, built entirely on rollers. The Athey wagon wheel tractor is one of the strangest pieces of heavy machinery ever built. A vehicle that didn't use ordinary wheels, tracks, or tires. Instead, it rolled on giant cylindrical drums, almost like a steamroller stretched into a full-sized tractor. Designed in the early 20th century by the Athey Company, this bizarre machine was intended for extreme off-road hauling in mud, swamps, and soft ground where normal tractors instantly sank. Its simplicity, odd appearance, and surprising effectiveness made it a legend among early heavy equipment collectors. Even more shocking, a few surviving units still start and move today. At first glance, the machine looks like a tractor sitting on 3 or 4 massive metal barrels. These wagon wheels weren't wheels at all. They didn't turn on an axle the way tires do. Instead, each drum rolled as the tractor pushed against the ground, creating a wide, stable surface area that kept the machine from sinking. The design was based on the principle of low ground pressure. By spreading its weight across enormous rollers, the Athey tractor could glide over mud, sand, and swampy terrain that would trap traditional equipment instantly. The power plant was usually a simple gasoline or diesel engine mounted on a basic frame. Chains or direct drive systems transmitted power from the engine to the rollers, allowing the machine to crawl forward slowly but steadily. It wasn't built for speed. It was built to move heavy loads in the worst terrain possible. Many versions were paired with roller-based trailers, creating entire Athey wagon trains that hauled timber, mining supplies, or construction materials across undeveloped land. One of the most unusual features of the tractor was its steering system. Because the rollers couldn't pivot like wheels, the machine relied on articulating frames or differential braking, essentially forcing one drum to rotate slightly more than the other. This gave it a surprisingly tight turning radius for such a strange vehicle, though it required a skilled operator to handle effectively. The Athey wagon wheel tractor became especially useful in logging operations. Loggers used it to drag huge loads out of deep forests where there were no proper roads. Its wide, stable rollers floated over debris, roots, and mud, making it far more reliable than early trucks or tractors with narrow steel wheels. Today, a handful of Athey roller tractors survive in museums or private collections. Some have been restored to working condition, proving that even a century later, this weird, drum-wheeled machine can still fire up and rumble across the ground. it remains one of the most unusual and innovative heavy machines ever created. Proof that sometimes the strangest designs are the ones that work best. The Marion 6360, the Captain, a stripper shovel the size of a building. The Marion 6360. The Captain wasn't just big, it was one of the largest land machines ever built by human hands. Completed in 1965 for the Southwestern Illinois Coal Corporation, this giant stripper shovel stood nearly 20 stories tall, weighed around 15,000 tons, and required so much steel that people joked it was a walking skyscraper. Nothing about the Captain was ordinary. It was a machine designed to move mountains, literally, stripping away massive layers of overburden to expose coal seams buried deep underground. Its enormous boom stretched over 215 feet, supporting a bucket so large that a pickup truck could fit inside it. With a scoop capacity of 180 cubic yards, the Captain could remove as much material in a single bite as several modern excavators combined. Each swing of its giant arm carved out massive chunks of earth, making it one of the most productive mining machines ever placed into operation. For the coal industry of the Midwest, the Captain wasn't just a tool, it was a revolution. Despite its size, the machine operated with surprising precision. Electric motors powered almost every function, drawing energy from high-voltage lines that fed the giant like an industrial-scale life support system. Inside the operator cab, workers controlled the behemoth through banks of switches, gauges, and levers. Operating it required skill, patience, and nerves of steel. Every movement had to be carefully controlled to keep the shovel stable. Even though it moved on gigantic walking shoes rather than tracks or wheels, the Captain could slowly walk across the mine, lifting itself and shifting forward one colossal step at a time. Life around the Captain became part of local legend. Miners told stories of how the ground shook when it walked, how its shadow swallowed trucks whole, and how it looked like a metal dinosaur rising out of the pit at dawn. Workers ate lunch in the shade of its bucket. Visitors standing next to it looked like insects next to a steel cliff. Sadly, the Captain's career ended in 1991 after a fire severely damaged major components. Repairs were judged too expensive, and the machine was eventually scrapped, an ending many mining historians still consider a tragedy. Only photos, memories, and a few salvaged parts remain. Yet, despite its fate, the Captain's legacy lives on. It remains one of the largest self-powered land machines ever built and a symbol of an era when American mining pushed engineering to its absolute limits. The Marion 6360 wasn't just big, it was a steel titan, unmatched in power, presence, and sheer industrial awe. The walking dragline, Big Musky Jr., the crane that walks itself. The machine known as Big Musky Jr. wasn't as huge as the legendary Big Musky itself, but it was still one of the strangest and most impressive draglines ever built, mainly because it didn't roll, didn't drive, and didn't run on tracks. It walked. With giant steel shoes instead of wheels, this dragline literally lifted itself off the ground and shuffled forward like a slow-motion mechanical creature. For miners seeing it for the first time, the machine seemed alive, almost like a metal dinosaur creeping across the landscape. Built during the era when coal companies invested heavily in massive stripping equipment, Big Musky Jr. was designed to remove overburden quickly and efficiently. It stood several stories tall, with a long boom capable of reaching deep into pits and pulling out huge loads of material. Its bucket could scoop dozens of cubic yards of earth in one bite, swinging it over to dump sites with the steady, rhythmic motion typical of dragline operations. But what made the machine unforgettable was the way it moved between cuts. Instead of driving, Big Musky Jr. relied on a pair of giant walking shoes connected to hydraulic push-down legs. When operators activated the system, the feet pressed firmly into the ground, lifting the entire machine an inch or two at a time. Then the body shifted forward, and the legs repositioned for the next step. This repeated over and over, allowing the machine to walk slowly across a mine site. It couldn't move fast, only a few feet per minute, but it could travel across terrain that would destroy wheels or tracks. Mud, soft ground, and uneven slopes didn't matter. Big Musky Jr. simply stepped over them. Inside the operator cab, running the dragline felt like commanding a small industrial city. Panels of switches controlled the walking system, the hoist ropes, and the swing motors. Electric power fed the dragline through heavy cables connected to nearby substations. Operators described the experience as both thrilling and intimidating. One wrong move could cause the machine to tilt or dig too deeply, so precision mattered with every swing of the bucket. Despite its size, the dragline earned a strong reputation for reliability. Many mining crews used it for decades, praising its rugged construction and simple mechanical layout. Even after newer, more automated machines appeared, Big Musky Jr. continued to work thanks to its durability and ease of maintenance. Although retired today, the walking dragline remains a unique reminder of an era when engineering pushed boundaries and built machines that seemed almost alive. Big Musky Jr. may not have been the biggest, but as a crane that walked itself, it was certainly one of the weirdest. The LeTourneau LP dozer, a bulldozer powered by electric motors. The LeTourneau LP dozer is one of the strangest bulldozers ever built, not because of its size, shape, or blade, but because of what powered it. At a time when nearly every heavy machine on Earth relied on diesel engines and mechanical transmissions, LeTourneau engineered a bulldozer that ran almost entirely on electric motors. Long before hybrid cars or battery-powered equipment became common, the LP dozer was proving that electricity could move mountains, literally. Designed in the 1940s and 1950s by legendary inventor R.G. LeTourneau, the LP dozer was part of his lifelong obsession with electric drive machinery. Instead of using a diesel engine to turn gears, shafts, and clutches, the LP used a diesel generator to produce electricity. That power then fed large traction motors mounted directly in the dozer's hubs. The result was a machine with no conventional transmission, no torque converter, and almost none of the mechanical stress found in standard bulldozers. It was smooth, powerful, and far ahead of its time. Operators who ran the LP dozer said it felt completely different from anything else in the dirt. Electric motors delivered instant torque the moment the operator touched the controls. There was no lag, no gear shifting, and no engine bogging. When pushing into a pile of earth, the machine responded immediately and evenly, as though it had infinite strength. This made the LP especially effective for heavy dozing, ripping, and moving large volumes of soil where traditional machines struggled. The LP's design was also futuristic in appearance. With its tall stance, unique frame layout, rear-mounted generator, and oversized electric hubs, it looked more like a prototype from a science fiction film than a piece of mining equipment. Even the operator controls were unusual, using electric switches and rheostats instead of levers and hydraulic valves. Mechanics marveled at the simplicity of the drivetrain. Because of the electric drive, there were far fewer moving parts to wear out. But the same technology that made the LP groundbreaking also limited its widespread use. Maintaining the electric components required specialized knowledge, and some mines preferred to stick with the simpler, conventional diesel mechanical dozers they already knew. As a result, only a small number of LP dozers were built, and they became rare machines seen mostly in large earth-moving projects and remote mining operations. Despite its limited production, the LeTourneau LP dozer remains one of the most fascinating engineering experiments in bulldozer history. It proved that electric drive could outperform traditional systems decades before the mining industry adopted hybrid and electric machines. Today, a few surviving LP dozers still run, massive, strange, and astonishingly ahead of their time. The JCB DieselMax Streamliner, a tractor engine going 350 miles per hour. The JCB DieselMax Streamliner is one of the strangest machines ever built, not because of how it looks or what it does on a farm, but because it took a tractor engine and pushed it to speeds no one ever imagined possible. In 2006, this long, needle-shaped rocket car stunned the world by reaching 350.092 miles per hour, breaking the land speed record for a diesel-powered vehicle. And the wildest part? Its power came from engines originally designed for JCB tractors and construction machines. Built by the British company JCB, the DieselMax wasn't created to plow fields or move dirt. Instead, it was developed to prove the engineering strength of JCB's DieselMax 444 engine, a 4.4-liter four-cylinder diesel typically found in backhoes and agricultural machinery. For the Streamliner, engineers modified two of these engines, heavily strengthening the internals and fitting them with twin turbochargers and advanced cooling systems. Each engine produced more than 750 horsepower, and together they delivered over 1,500 horsepower at full boost. That is an astonishing figure for a diesel engine originally meant to power work machines, not break speed records. The DieselMax Streamliner itself looked nothing like a tractor. It was a long, narrow, low-slung land rocket, measuring nearly 30 feet in length but barely wider than a person. With its sharp nose, aerodynamic carbon fiber body, and enclosed wheels, it sliced through the air with incredible efficiency. Its shape was so streamlined that wind resistance at 350 miles per hour was lower than that of many sports cars at 150 miles per hour. Every inch of the machine was optimized for speed, yet under the skin, its heart was still pure diesel. In August 2006, the JCB team brought the DieselMax to the Bonneville Salt Flats in Utah, the historic home of land speed records. Conditions were challenging, but driver Andy Green, already famous for piloting the Thrust SSC to the supersonic land speed record, guided the DieselMax with precision. On the record-setting run, the Streamliner accelerated smoothly, its twin diesel engines roaring like nothing ever heard on the salt. When the timing lights confirmed 350 miles per hour, the DieselMax officially became the fastest diesel car in history. What makes this machine so weird and wonderful is the contrast between its purpose and its origins. A tractor engine pushing a car faster than a commercial airplane at takeoff speed? It sounds impossible. Yet JCB engineers made it real. Today, the DieselMax's record still stands, and the machine remains a shining example of how creative engineering can turn everyday machinery, yes, even tractor engines, into something extraordinary. The Crest coal hauler, the one-wheeled rear monster truck. The Crest coal hauler is one of the strangest-looking heavy machines ever put to work. At first glance, most people can't believe it's real. Instead of the usual 4 giant wheels seen on mining trucks, the Crest coal hauler has 2 massive wheels in front and 1 enormous wheel in the back, making it look like a gigantic industrial tricycle hauling hundreds of tons of coal. It may look bizarre, but it was designed this way for a reason, and the results turned it into one of the most effective coal hauling machines ever built. Even today, several of these unusual haulers are still working in coal mines around the world. Crest Corporation designed the coal hauler to solve a major mining problem. Traditional haul trucks were struggling with tight turns, uneven terrain, and narrow haul roads inside large coal operations. Their rigid frames and long wheelbases made them difficult to maneuver. Crest engineers realized that if they could pivot the entire rear of the machine around a single massive wheel, the truck would gain incredible turning ability and smoother handling, especially on steep or winding routes. This led to the creation of the iconic rear single-axle design, supported by a giant 14-foot-tall tire that acts almost like a pivot point. The coal hauler's tricycle layout gives it one of the tightest turning radiuses of any heavy hauler in the world. Instead of swinging wide like other mining trucks, a Crest hauler can almost rotate around itself, making it perfect for crowded pits or narrow benches. The massive rear wheel also distributes weight more evenly when the machine is loaded, helping reduce ground pressure and improving stability on soft or uneven terrain. Powering this strange beast is a huge diesel engine, often a Caterpillar 512, generating thousands of pound-feet of torque. The machine can carry 200 to 240 tons of coal in a single load, depending on the model. The payload sits in a long, low-slung bed that keeps the center of gravity stable during movement. Unlike tall dump trucks, the Crest hauler's low profile lets it operate under low ceilings, conveyor systems, and tipple structures in coal mines. Another odd but brilliant feature is the machine's rear suspension system. Because the entire load rests on one giant wheel, Crest engineered an advanced hydraulic suspension to absorb shocks and keep the hauler stable. Operators often say that a fully loaded Crest hauler rides smoother than many traditional haul trucks. While it looks like something out of a sci-fi movie, the Crest coal hauler is a purpose-built workhorse. Its unusual design wasn't created to turn heads, but to solve real mining challenges. And decades later, these one-wheeled rear monsters are still hauling coal, proving that weird engineering sometimes becomes the best engineering. The LeTourneau log stacker, a forklift taller than a house. The LeTourneau log stacker is one of the most breathtaking, bizarre, and flat-out massive machines ever used in the timber industry. Imagine a forklift so tall it can look straight into a second-story window. Imagine lifting entire piles of logs with arms the size of telephone poles. That's the LeTourneau log stacker, an industrial giant that dwarfs even the largest construction equipment. With some models reaching over 35 feet tall and weighing more than 150 tons, it's no exaggeration to say this thing is a forklift the size of a building. Designed by R.G. LeTourneau, the engineering mastermind behind some of the world's biggest off-road machines, the log stacker was built for one purpose: move massive quantities of timber faster than anything else. Traditional loaders struggled to handle the huge log piles created by modern logging operations, especially in pulp and paper mills. LeTourneau's solution wasn't to improve the old machines, it was to redesign the concept entirely, building a forklift on a scale the world had never seen. The stacker's signature feature is its gigantic front lifting arms, capable of grabbing entire bundles of logs at once, sometimes 30, 40, or even 60 tons of timber in a single bite. These arms are powered by enormous hydraulic cylinders, allowing smooth lifting even under extreme weight. The forks themselves can be as wide as a small car, engineered to slide under massive log piles like a giant hand scooping up firewood. But what truly sets the log stacker apart is its electric drive system. Like many LeTourneau machines, the stacker uses diesel-electric power. Its diesel engine doesn't turn wheels directly, but instead acts as a generator for huge electric traction motors. This gives the machine incredible torque, smooth acceleration, and unmatched durability in harsh environments. Electric drive also reduces maintenance and keeps the machine running even under punishing workloads. Visibility is crucial when handling towering log piles, so the operator's cab is perched astonishingly high, often higher than a house roofline. From this vantage point, the operator can see the tops of log stacks, the yard layout, and trucks maneuvering below. Despite the machine's size, operators say it drives smoothly thanks to its articulated steering, which lets the front and rear halves of the vehicle pivot. Even decades after their introduction, LeTourneau log stackers are still working in timber yards across North America, Australia, and South America. Their reliability, lifting power, and sheer scale have kept them indispensable in an industry where moving thousands of tons per day is normal. The LeTourneau log stacker isn't just a weird machine, it's a mechanical skyscraper on wheels, proving that sometimes the best way to move mountains of logs is to build a forklift taller than a house. The Snow Cruiser, America's Antarctic landship. The Snow Cruiser is one of the strangest and most ambitious vehicles the United States ever built, an enormous, wheel-driven landship designed to conquer Antarctica. Created in 1939 for Admiral Richard Byrd's polar expeditions, the Snow Cruiser was supposed to be a mobile research base capable of crossing crevasses, surviving blizzards, and traveling thousands of miles across the frozen continent. Instead, it became one of history's most spectacular engineering oddities, an icebound giant that looked more like a science fiction spacecraft than a piece of machinery. Measuring 55 feet long, 20 feet wide, and weighing over 37 tons, the snow cruiser was bigger than many houses at the time. It carried its own machine shop, research labs, living quarters, and enough fuel to travel 5,000 miles without resupply. The design was bold. 4 enormous Goodyear tires, each 10 feet tall, were tucked into the body for streamlining and could be raised or lowered hydraulically. The idea was that if the cruiser reached a crevasse, the wheels could retract and allow the entire chassis to slide across the gap like a sled. Power came from 2 diesel-electric engines, very advanced for the era, which allowed smooth torque delivery even in extreme cold. The snow cruiser also carried spare wheels mounted on the rear, designed to be dropped down and used as additional traction in emergencies. Engineers believed the cruiser would revolutionize Antarctic travel, providing a safe, warm, mobile base that could explore farther than humans ever had. But when the machine finally arrived in Antarctica, it encountered a problem no one expected. The tires couldn't get traction on ice. Instead of gripping, they spun helplessly. The crew tried lowering tire pressure, even to the point where the rubber nearly collapsed, but it only helped slightly. A vehicle designed to glide over the frozen world instead struggled to move a few feet at a time. Despite these issues, the snow cruiser was used as a stationary shelter during the expedition, serving as a warm refuge in the brutal Antarctic environment. When World War II began, the team abandoned the cruiser and returned home. For decades, it sat buried in snow until a U.S. expedition rediscovered it in 1958, still intact, with tools and equipment inside just as the crew had left them. Soon after, shifting ice covered it again, and it has never been seen since. The snow cruiser remains one of the weirdest heavy machines ever built, an Antarctic landship ahead of its time, remembered as much for its bold vision as for its frozen fate. The Demag B406 bucket wheel, the excavator with a spinning mouth. The Demag B406 bucket wheel excavator is one of the strangest-looking mining machines ever created. An enormous steel creature with a giant spinning mouth that chews through earth like a mechanical monster. Built in Germany during the mid-20th century, the B406 was part of the early rise of massive, continuous mining machines. Unlike traditional excavators that dig one scoop at a time, the B406 used a rotating wheel lined with buckets to carve through soil non-stop, ripping away thousands of tons of material per hour. To watch it work was to witness a metal beast devouring the ground in front of it. Standing over 150 feet tall and weighing thousands of tons, the B406 was built for brown coal, lignite mining, one of the most demanding industries in Europe. Brown coal seams are often shallow and spread across massive open pits, meaning mining companies needed machines capable of continuous excavation across huge areas. The B406 answered that call, with its enormous bucket wheels spinning at speed, scooping up dirt, coal, and clay, and sending the material onto massive conveyor belts for transport. Its most iconic feature, the bucket wheel, held over a dozen steel buckets, each capable of tearing into the earth with every rotation. The wheel didn't dig like a shovel. Instead, it sliced through the soil, the way a spinning saw cuts wood. The buckets, arranged around the rim, swallowed material and dumped it onto an internal chute that fed the conveyor system. This gave the machine its strange visual identity, a towering mining giant with a rotating, open-mouthed face. The B406 wasn't just massive, it was mobile. Despite weighing more than a battleship turret, it moved across the mine using huge tracked undercarriages. It crawled slowly but steadily, advancing as the bucket wheel removed layer after layer of overburden. Its long boom could reach deep into the pit wall, and the machine could pivot its entire structure to reposition the wheel. Operators worked from elevated cabs that gave them sweeping views of the mine, though controlling the B406 required immense skill and intense coordination with the conveyor network. Even stranger, Some B406 units from the 1960s and 70s are still working today in parts of Eastern Europe. While newer, larger bucket wheel excavators exist, the B406 remains a symbol of early mega-machine engineering. Simple, rugged, and built to last. With its spinning steel mouth and relentless appetite for Earth, the Demag B406 stands as one of the weirdest heavy machines ever built. A mechanical dinosaur still chewing through the planet one bucketful at a time. The Herrenknecht tunnel mole, a subterranean metal worm. The Herrenknecht tunnel boring machine, often called a tunnel mole, is one of the strangest and most impressive pieces of heavy machinery ever created. Unlike bulldozers, excavators, or cranes that work above ground, this machine operates deep beneath the surface, carving tunnels through earth and rock like a gigantic metal worm. Built by the German company Herrenknecht AG, these moles have dug subway tunnels, water pipelines, hydroelectric systems, and even undersea passages. Seeing one in action feels like watching a science fiction creature come alive underground. At the front of every Herrenknecht tunnel mole sits a colossal rotating cutter head, sometimes over 40 feet in diameter. The circular face is lined with steel teeth and cutting discs designed to grind through soil, clay, bedrock, and even reinforced concrete. As the cutter head spins, it chews away at the ground, turning solid earth into loose material that can be transported out of the tunnel. The process is continuous, controlled, and surprisingly smooth, allowing the machine to carve perfectly round tunnels with almost surgical precision. Behind the cutter head lies the machine's long, segmented body, sometimes stretching hundreds of feet. This is where the real, worm-like structure appears. The tunnel mole moves forward by pressing hydraulic cylinders against pre-installed tunnel segments or against the surrounding rock. Each push advances the machine a few inches at a time, giving it a slow but powerful crawl through the earth. As it moves, the rear section of the machine installs concrete lining pieces to reinforce the tunnel, making it safe and stable. Even stranger, the entire machine operates under constant computer monitoring. Laser alignment systems, pressure sensors, and navigation controls help guide the mole deep underground. If it drifts even a few inches off course, the results could be disastrous, so precise steering is essential. Operators work from a control cabin inside the machine, surrounded by screens showing soil pressure, cutter torque, temperature, and tunnel alignment. It's like piloting a submarine through solid ground. Despite being hidden underground, Herrenknecht moles are massive. Some weigh more than 4,000 tons, making them heavier than many surface mining machines. Transporting and assembling one can take months, but once it begins moving, it can dig for miles, sometimes without stopping for more than a year. Today, Herrenknecht tunnel moles continue carving new passages beneath major cities like London, Shanghai, and New York. They are engineering marvels, subterranean metal worms that quietly reshape the world from below. The Ruston-Bucyrus walking dragline, the two-legged earth mover. The Ruston-Bucyrus walking dragline is one of the strangest and most impressive machines ever built. A massive earth mover that doesn't roll on wheels or run on tracks, but actually walks on two giant steel feet. Designed in the mid-20th century for open-pit mining, this weird mechanical giant proved that sometimes the best solution for moving thousands of tons of earth is a machine that takes steps instead of driving. At first glance, a walking dragline looks like a cross between a crane, a tank, and a science fiction robot. The upper structure holds a massive boom, often more than 200 feet long, that carries a huge bucket at the end. This bucket can scoop 30 to 60 tons of material in one bite, making the dragline ideal for clearing overburden above coal seams. But what makes the Ruston-Bucyrus version truly unique is how it moves across a mine site. Instead of tracks or wheels, the machine sits on a large circular base. When it needs to move, hydraulic systems lift the entire machine, sometimes weighing thousands of tons, off the ground. Underneath, two huge steel shoes slide forward. Then, the machine lowers itself onto these shoes and drags the base forward. This creates a slow, shuffling step that allows the dragline to cross soft or uneven terrain where tracked vehicles would sink or stall. It's not fast. Most walking draglines move at a speed of only 1 or 2 steps per minute. But speed isn't the point. Stability and ground pressure are everything. The walking system spreads the machine's weight over a much larger surface area, allowing it to operate on muddy, sandy, or loose soil without sinking. This was especially important in coal mines where ground conditions constantly changed. The design also eliminated traditional undercarriage wear, which saved mining companies huge amounts of money over the years. Operators inside the cab had to manage not only the bucket and boom, but also the careful rhythm of the walking cycle. Timing and coordination were crucial. A single misstep could twist the frame or destabilize the machine. But once mastered, the Ruston-Bucyrus dragline could move enormous amounts of earth with surprising efficiency. Many of these walking giants remained in service for decades. Even today, a few restored units still operate in small mines or are displayed as historic machines. Their strange, two-legged walk continues to fascinate engineers, equipment fans, and anyone who sees them in motion. The Ruston-Bucyrus walking dragline stands as one of heavy machinery's weirdest inventions, an earth-moving behemoth that didn't drive but walked its way into mining history. The Kamasu amphibious excavator, a swamp machine on floats. The Kamasu amphibious excavator is one of the strangest-looking pieces of heavy machinery ever built. Instead of the usual steel tracks found on standard excavators, this machine sits on giant pontoon-style floats, allowing it to operate in swamps, wetlands, flood zones, and shallow water where normal equipment would instantly sink. It looks part excavator, part boat, and part oversized marsh creature, yet it remains one of the most practical machines ever created for extreme terrain. Kamasu designed the amphibious excavator for jobs where traditional equipment simply cannot survive. Soft mud, deep marsh, and unstable riverbanks create ground pressure too weak to support the weight of Herrenknecht-tracked machines. To solve this, Kamasu replaced the undercarriage with long, hollow pontoons made from reinforced steel. These pontoons act like flotation devices, distributing the machine's weight so evenly that it can glide across muck that would swallow a bulldozer in seconds. In deeper water, the pontoons even provide partial buoyancy, allowing the machine to float, walk through areas that resemble a swamp more than a construction site. Despite its strange appearance, the amphibious excavator works just like a normal excavator from the operator's seat. The boom, stick, and bucket are fully functional, allowing it to dig canals, clean riverbeds, remove sediment, build levees, and perform environmental restoration. The machine can scoop mud from underwater without losing stability, thanks to the pontoon's wide stance and the long reach of its extended boom options. In many coastal and wetland projects, it is the only machine that can operate continuously without getting stuck. The tracks mounted on the pontoons use a special chain and pad system that grips into mud and waterlogged soil. Instead of spinning helplessly like standard tracks, these wider pads create traction even in floating conditions. Some models come with auxiliary hydraulic drives for even greater maneuverability, allowing them to pivot smoothly across swamp surfaces. One of the amphibious excavator's greatest strengths is its ability to work in fragile environments with minimal damage. Traditional heavy machinery destroys wetlands due to high ground pressure, but the Kamasu amphibious excavator spreads its weight so broadly that it leaves behind surprisingly little disturbance. This has made it invaluable for ecological restoration, hurricane recovery, and maintenance of river channels and irrigation systems. Even more impressive, many of these machines still run after years of service in brutal, muddy conditions. As long as the pontoons are maintained and sealed, the excavator remains dependable and surprisingly agile. The Kamasu amphibious excavator is a true engineering oddity, a swamp-ready hybrid that walks on water, glides through mud, and tackles jobs no other machine can handle.